Okay, if you had a friend and you were like, I kind of like this friend, but they're like a complex person. What would make somebody a complex person? Like they're like cool, but they're a little complicated. They got a lot of things going on. Maybe sometimes they're like real, but sometimes they're like fake. Okay. Complex numbers are the same way. They are real and fake at the same time. So over here, we have a complex number is a number that can be written as a plus bi, where it has a portion of the number that is real and a portion of the number that is fake. Imaginary. That's why it has an I in it. So because part of the number is real and part of the number is fake, that makes it complex. And we're just going to always remember that I comes from the square root of -1. We also know that I squared equals -1 exactly, if that's the case. All right, so the reason that I squared is -1 is because if I was to take this right here, if this is what I equals, if I was to square this, what would happen to the radical? If you have a radical and you square it, where does the radical go? You have a radical, the square root sign. You have a radical and you square it, it goes away. You undo it, right? And then the -1 is left behind. Let me show you that because I'm seeing just a little bit of confusion. So if I have the definition of I is that I equals the square root of a negative number, so the most simple version of that is that it's the square root of -1. So if I want to figure out what I squared is, I'm just going to square each side of this, right? And then the squared and the square root cancel out. And I just get I squared equals -1. Does that make sense? Okay. So we have two things here. We have I equals the square root of -1, and we have I squared equals -1. Two things. Okay, we're just going to make sure we remember those two things. Okay, so for today, we are going to look at what complex numbers are, and then we're going to look at how to add and subtract them and how to multiply them. And to be able to do that, we just have to remember those two things, that I is what happens when you get a negative under a radical, and that I squared is just -1. We can replace, anytime we see an I squared, we can replace it with a -1. So if we look at these first examples, if you see this problem 2 plus 7i, the real portion is the 2, the imaginary portion is the 7i. If you see a complex number that says 3i, then the real portion was 0, and they just didn't write it down because you don't have to write 0 plus 3i, you can just write 3i. And the imaginary portion is 3i. What's the real portion for the next problem? -3, and the imaginary portion is? -6i. Okay, and then for the last one, what's the real portion? 23, and what's the imaginary portion? 0i. Perfect. Okay. All right, if we look at the next part, for us to add or subtract complex numbers, it's basically combining like terms. So if you add complex numbers, you have to keep the real numbers together and you keep the imaginary numbers together. So you combine the like terms. So if we wanted to find the sum of 5 plus 3i, this complex number plus this complex number, then we would say the real numbers added together is 9, and the imaginary numbers added together is 5. Does that make sense? Because you combine like terms. Okay, now they gave us a more complicated version for this next one because they have like just alternating signs. So I'm not even going to look at this part where they showed their work. But if we had 3 plus 7i minus -1 plus 2i, whenever you see complex numbers, they're always going to put it in parentheses. And the reason they do that is because even though it's two terms, it represents one number because it's one complex number that happens to have two parts. Does that make sense? Okay, so if we have the first complex number, 3 plus 7i, and we are subtracting off the second complex number, we have to make sure that we subtract both pieces of it. We subtract the real number piece of it, and we subtract the complex or the imaginary number piece of it. So I'm going to be subtracting a -1. What happens when I subtract a -1? Turns to a positive. Minus minus makes a plus. And then I'm subtracting 2i. So you can see that when I do that, +3 and +1 would give you 4. 7i and -2i would give you 5i. So if we're doing a subtraction problem, we just have to make sure that we distribute the negative to both terms of the second complex number. We just have to be careful to distribute negatives. Okay, so let's go ahead and let's try problem A. So if we're adding these two together, we have 2 plus 11i, 2 plus 11i. What's the real number portion? 4. And what about the imaginary portion? Plus 22i. Okay. All right, for this one, I'm going to go ahead and distribute the negative. So I have -5 minus 7i, okay? So now if I write the real number portion down, what's the real number portion? -5, okay? And then what about the imaginary number portion? What is it? -10? Okay, -10i, okay? For the next one, what's the real number portion? 12. And what's the imaginary portion? +5i. Okay. For this next one, I'm going to distribute the negative. So -5 plus 12i. Okay. What's the real number portion? -12, good. And then what's the imaginary portion? 13i. So we just make sure that whenever we write complex numbers, we don't think of the I as a variable because it's not. It's just talking about an imaginary number. And it is proper to write the real number first. So I is not a variable. This is not like, oh, we write our x's first, we write our numbers second. It's not like that. This is real numbers and imaginary numbers coming together to make one complex number. We always write the real number first, the imaginary number second, and the order matters because this is what is proper. Does that make sense? Okay. If you wrote them backwards, I probably wouldn't mark you like completely wrong for an answer. Whenever I grade things, I don't do completely right or completely wrong. I do partial credit. Okay. So if you wrote them backwards, I wouldn't say, oh, your whole answer is wrong. I would take off like half a point or something. Okay. All right. For the next one, our whole number, our real number answer is what? 32. And our imaginary answer is -19i. Okay. How do we feel about those? Great? Pretty good? Okay. All right. The next type of problem that we're going to be doing for today is we're going to be multiplying. These are just a little bit more complicated, truly not much more complicated, but a little bit more complicated because we're going to start running into I squareds. So we have to make sure that anytime we see an exponent of I, that we think about, is it just I squared, so I just replace that with -1, or could it be like an I to the third? And an I to the third has an I squared, and then it has one extra I. So an I to the third would have a -1, but then it would have an extra I with it. Does that make sense? or an I to the fourth is actually an I squared times an I squared. So an I to the fourth would actually be a -1 times a -1. So whenever we see exponents of I, we have to think about, oh, how many -1s are in there? Or how many leftover i's are in there. And typically when you're doing problems, you're not going to have a ton of them left over, to be honest, unless somebody is being crazy and they're like, hey, what is I to the 63rd power? And some people do that just because they want you to think about it. But most of these problems, the highest they're going to get is like I to the third, I to the fourth, something like that. I squared is the most common. So really that's just what we have to remember. Okay, so if you see two sets of parentheses next to each other, you're going to have to remember to FOIL if you see the two sets of parentheses next to each other, just like we would always do if we saw two parentheses next to each other. Otherwise, if you see something next to a set of parentheses, you're just going to have to remember to distribute. Simplify your powers of I and keep in mind that I squared is -1, and then do all your combining of like terms. So if we look at this first example, they start off with 4 minus 3i and 2 plus 5i, and the first thing they did is they multiplied 4 times 2 and they got 8. We good with that? 4 times 2 is 8? All right. Then they did, let's see, where'd they get the 6? Oh, they're going out of my FOIL order. 4 times 5i right here is the 20i, so there's the 8, there's the 20i. And then they did these two, -6i. And then these two, there's the -15i squared. Do we see all the terms, where all the terms came from? Okay. So next, they saw the I squared, and they took the I squared and they turned it into a -1. Right here, turned it into a -1. So we have -15 times -1 gives you what? Positive 15. So that right there became a positive 15. And then right in here, we have these two like terms, -6i and positive 20i. Those give you what? Well, they're just imaginary numbers. They are like terms. So a -6i and positive 20i would give you 14. So these like terms right here, you could have added them together in the first step or the second step or the third step, but they waited until the end to add them together, and they said that was 14i. And then you have the 8 from the beginning, and now we have a 15 on the end because that I squared became a -1. Only when it's multiplying do you get the exponent. Otherwise, it's like terms. Yeah, good question. So 8 and 15 gives you 23. So your final answer is 23 for the real number, 14i for the imaginary number. Does that make sense? Okay. So another type of problem that's pretty common with multiplication is if they give you a complex number and they ask you to square it. So 7 plus 2i squared. Now we need to make sure that we're not just taking the exponent and distributing that, because that's not how squared works, not when you have a plus in the middle. So if you're taking something and squaring it and you have a plus in the middle, it means you have to write the parentheses twice. All right, so write it twice and then FOIL it out. So they started the foiling process. They did 7 times 7 is 49, 7 times 2i is 14, 2i times 7 is 14, 14i, and then 2i times 2i is 4i squared. And then they did the 4 times the -1. They took the I squared out and they did 4 times -1. And what would you get for this 4 times -1? -4. Okay, so let's figure out what that final answer should be. So we have the real number, which is 45, and we have the imaginary number, which is 28i. Perfect. Has anyone been doodling on the notes? Because these are doodle notes. I don't know if you noticed. There's places to color on here.
I know, I have been.
Have you guys been coloring? Is it nice? Do you like them? Do you like them? Okay. I'm glad. I'm glad you guys like them. All right. So we have the only part we're going to do to finish the notes today is just this little box. We are almost done with the notes. All right. So let's go ahead and let's get these two sets of parentheses foiled. So if you multiply them out, what do you get? 4. And then what else? 22i. Plus 22i. Another 22i. And then 121i squared. But an I squared isn't really an I squared. It's really a negative 1. So positive 121 times negative 1 is what? Okay, so this is a negative 121. Okay. So we have a positive 4 and a negative 121.
Wait, so how'd you use that again?
Because an I squared is a negative 1. So if we had a positive 121 multiplied by a negative 1. Negative. Mm-hmm.
Oh, that's your answer. Oh,
mm-hmm. Mm-hmm. Oh yeah, I didn't feel like writing it again.
My bad.
Yeah. So negative 121 and positive 4. Negative 117. And then 22i and 22i. 44i. Okay, there's our complex number. Okay, next one. If we take this, we have a imaginary number multiplied by a complex number. And so we're just going to go ahead and distribute because we only have one set of parentheses. So negative 3i multiplied by 5, negative 15i. Negative 3i multiplied by 7i, negative 21i squared. And if you have a negative 21 multiplied by an I squared, it's just a positive 21. And so now how do you have to fix this to write the answer correctly? 21 minus 15i.
Wait, so the I can
Mm-hmm. Okay, one last example. Have you guys seen something like this before where they are almost identical but they're the opposite sign? What does that remind you of? Plus or minus. It reminds us of factoring a little bit. It is difference of squares. Yeah, it's like the factors for difference of squares. There's actually a word for this. It starts with a C. Conjugates. Conjugates. So these are actually conjugates, and they're really helpful in math. They're a nice tool, and we're actually going to see tomorrow what they're a tool for. So you kind of already know what they're going to do because we're going to take essentially like the factors of difference of squares and we're going to multiply them out. But today we're going to FOIL them and see what happens. And then tomorrow we're going to realize like, oh, conjugates are kind of a nice tool. This is probably the first time we're ever going to use conjugates as a tool, is not tomorrow actually, but the day after. And then from then on in math, we use conjugates periodically as a tool. So let's go ahead and FOIL them. We have 8 times 8. And then 8 times 6i. 48i. And then 6i times 8. Negative 6i times 8. And then negative 6i times positive 6i. Okay, so the negative 36i squared is actually a positive 36, okay? And then what happens with these middle terms? They cancel out because of one of these being a minus and one of those being a plus. They happen to alternate signs, which makes them cancel out. That's the beauty of the conjugate, is that it makes the middle terms cancel. Okay, so we have 64 and 36, and if we add those together, what do we get? 100. So in this case, when we multiplied two complex numbers together, if they were conjugates, what type of answer did we get? Just a real number. It ended up just being a real number. Okay, so what we're going to be doing for today's practice assignment is we're just going to be adding numbers, subtracting, and multiplying complex numbers. Sound good? Okay. Now, tomorrow in class, we're going to be having a quiz, and the quiz is going to be on the stuff we've learned so far. So it's going to be on factoring, solving by factoring, quadratic formula, and then it might have like a little bit of the complex numbers, but the focus of the complex numbers is going to be the later part of this unit. Okay? So it's mostly going to be on factoring, solving by factoring, and quadratic formula. Okay? Sound reasonable for the quiz? Okay. All right, let me go ahead and get this assignment handed out. So if you simplify this first problem, what do we do with this negative? Make it a positive, turn it into an I. What's the square root of 4? 2, so the answer here is 2i. Since it has an I, we're going to shade this square. Okay, which direction do you guys want to go? Down. Okay, it says, to follow the path of the complex numbers. All right, so this one we need to distribute. And what do we get when we distribute? 6 plus 4i has an I, so we're going to shade. So that's all you have to do is you just follow the path of the problems that have i's in them. If you solve the problem and it does not have an I, like with this one, if you had gone to the left and you did this, it would have been 6i squared. 6 times I squared is negative 6. That does not have an I, and so you would not shade that box. You would not go that direction because it did not have an I in it. Does that make sense? Okay, so you're going to follow this. It's going to kind of snake its way through, and then the ending box is over down here. All right?